Today we're diving into something groundbreaking from Meta that can reshape the AI landscape. Large concept models, or LCMs. Think of this as the next evolution in language models, moving beyond just words into the realm of abstract ideas. Intrigued? Let's break it down. Let's start with what we know, large language models, or LLMs. Like the ones powering tools such as chatgpt. They're amazing, but there's a big catch. They're stuck at word level. What do I mean with stuck at word level? Well, LLMs work through tokenization, the core of how most AI models like ChatGPT or BART work. Think of tokenization like breaking down a sentence in bite-sized pieces so the AI can digest them. Each word, or even parts of words, becomes a token. Imagine a sentence like this: AI is awesome, as displayed in the picture. Gets broken down into tokens like AI, is, and awesome. But here's the problem. When AI works at the token level, it's like assembling a puzzle piece by piece. It doesn't always see the whole picture right away, and that's why it sometimes gets stuck or repeats itself. Now here's where LCMs flip the script. Instead of breaking down a sentence into tiny tokens, it looks at the whole sentence as a single idea, a concept. It's like skipping the puzzle building stage and just seeing the finished picture immediately. This lets it reason and generate outputs more like humans do. That's the magic of LCMs. To pull this off, Meta uses a technology called sonar. But don't worry, it's not actually a submarine radar. Sonar is a special tool that takes sentences and turns them into concepts, basically compact bundles of meaning. And this works across 200 languages. And yes, even low resource ones. Think of sonar as a universal translator for ideas. It doesn't care what language you're speaking, or even if it's text, speech, or something else. It just takes your sentence, finds the core idea, and stores it in a way that's language agnostic. Imagine you're traveling abroad, and someone explains something in a language you don't even speak. If a friend translates the meaning, instead of word for word, you would still understand. That's exactly what sonar does. Captures the essence of the message, not just in words. Sonar is the reason LCMs can handle 200 languages for text and even 76 for speech. It makes the AI smarter, faster, and capable of understanding the bigger picture, no matter how the message is delivered. LCMs could make AI tools smarter and more adaptable, helping with everything from writing and brainstorming to multilingual communication. Plus, their ability to understand abstract ideas means we're stepping closer to AI that thinks more like us. Will this be adapted by other AI companies and used as a new foundation? Or could LCMs and LLMs combine? I guess we will have to wait and see. To end this video, I would like to show you an interesting short video.
So I'm really happy, to be here. It's always a pleasure to be in this place and with so many familiar faces. I'm really looking forward to see what you respond to what I have to say. So maybe I want to start by going back to some of the definition. When we talk about scaling, what do we mean? Anil said, anything that could come up in the next 5 years. So of course, the main tool, as you all know, is the next word prediction on a very, very big model. That's one aspect of scaling. That's of course not what I'm saying. I'm not saying that just scaling up, making a bigger model on a bigger data set with just next word prediction, that will at some point create a machine where you can just ask, prove me the Riemann hypothesis, and then it goes and writes a proof. That's not what we're talking about, okay? Just to make sure. And to emphasize this point further, you can look at the gap between GPT-3 and GPT-3.5. GPT-3, that was a big model trained on the web, next word prediction, very, very classical. What could that model do? Well, it could write kind of shitty poems, maybe, not that great movie scripts. Of course, for us in this room, it was still completely shocking that it could do that. I mean, really, we have no tools to understand what's going on there. But GPT 3.5, that's the one that really shocked the world, that really made a big impact that can start to do stuff. And what is the difference between GPT-3 and GPT 3.5? It's the post-training. And the post-training, this is a crucial aspect where you're trying to control the model, really try to extract all of the intelligence that has been imbued with next word prediction. So next word prediction imbues the model with a lot of intelligence, and post-training extracts it and put it to something that we care about, some tasks that we care about. For GPT 3.5, it was chat. Okay, it was just having a chatbot. But now we have post-training techniques that can do a lot more than just extracting a chat model out of the big next word prediction machine. For example, we have reasoning post-training with the O series of model, and that's a completely new style of post-training. Okay, so this is what I'm talking about with scaling. Now, before trying to make the case for why I think that big major open problems could be resolved in the next few years, I also want us to just take a few minutes to take stock of the progress that has been made in the last few years. Because this progress, I think, is nothing short of miraculous. And I'm just going to talk about benchmark. I'm not a big fan of benchmarks. This was the whole point of the Sparks paper, to go beyond benchmarks. But for the sake of time, let's focus on benchmarks. So in the last few years, there is one benchmark that really rose to the top, which is MMLU. Somehow, all the big CEOs, they started to, Mark Zuckerberg started to talk about MMLU as kind of this really way to demonstrate the intelligence of a model, whether you're at 80%, 85%, etc. GPT-3 was at 50% on this benchmark. And MMLU is like kind of high school level science question style. Humans are at 90%. Okay. GPT-4 was already at 86%. O1, we're talking about 92, 95. I don't exactly know, but it's now it's basically in the noise level of the benchmark. So this benchmark, even though it rose to the point where it's moving stock market, it's moving the world economy. That's it. This benchmark is gone. It doesn't matter at all anymore. It's completely saturated. Okay, so we have to look beyond. Now, just recently there was a study that came out on medical diagnosis, comparing human doctors to GPT-4. Human doctors on that benchmark were getting 75%. Okay, so 3 out of 4 were correct. GPT-4 gets 9 out of 10. Okay, on medical diagnosis, like this is something that we care about, I care about in the real world, And GPT-4 is already beyond humans. Now, in that same study, they are already foreshadowing what happens with O1 and saying that there are now cases where human doctors are at 50% and O1 is at 90%. I mean, this is just, completely incredible. Now, closer to what we're talking about today, there was a math benchmark, which is high school competitive mathematics. And that quickly got saturated. Now we're talking about AMI. So AMI is a new benchmark that, OpenAI, for example, is using to benchmark the new O models. So AMI is this test to get into the US team for the IMO. O1, so GPT-4 is at essentially 0%, maybe 5%, maybe 10%. It's essentially 0%. O1 preview, I think, is already at 50%. You can see it. It's going to be at 90% next month, in 2 months, And the IMO gold medal is going to be, okay, I still have some time. And the IMO gold medal is going to be, I don't know when, but, very soon. For sure next year. There is just no question given the current trend. Okay, so this is the definition, taking stock of where we are. Now, what is the real argument? The real argument is not very deep and pretty simple. So the way I like to frame the discussion, and this is not by me, I don't know actually who came up with it, is in terms of AGI time. So how much, do you have an AGI second? Do you have an AGI minute? Do you have an AGI hour? Meaning, can you mimic what a human would do if they have just a few seconds to think, if they have an hour to think, if they have, a day to think? I think GPT-4, to me, I mean, that's what I wrote in Sparks, it's very clearly an AGI seconds. So it's clearly as good as basically any human who has just a few seconds to think. If you are, maybe it's already getting into AGI minutes in some cases, for example, in coding. Certainly not AGI minutes in mathematics. Okay, that was not the case. It was AGI seconds in mathematics. Now, when we go to O1, we're already talking, I think it's AGI minutes, like uniformly, and maybe it's already AGI hours in coding, for some math problem, not for you guys, but for the vast majority of the population is already AGI hours for mathematics. Like what will it take to resolve big major open problems is to have AGI weeks. I mean, that's it. That's all you need. You don't need anything else. If you have AGI weeks, then you have it. And you see the trend. We went AGI second, AGI minute, AGI hours. Will next year, will we have AGI day with, singular? Yeah, maybe, that's what an agent would be like. Will 2 years from now, will we have AGI days? Yeah, probably. 3 years from now, AGI weeks. So that's my argument.
Thank you for watching. Don't forget to subscribe if you liked the video. Did you subscribe already? I'm waiting. Thank you for subscribing.